Welcome to the Minnesota Stormwater Seminar Series. I am John Gulliver, and I will introduce the seminar series and our speakers. This series of seminars is co-sponsored by the Water Resources Center and the San Anthony Falls Laboratory, both at the University of Minnesota. We have two speakers today, Tom Schueler and David Wood. Tom and David are the Executive Director and the Stormwater Coordinator, respectively, of the Chesapeake Stormwater Network, a nonprofit organization devoted to implementation of more sustainable stormwater practices across the Chesapeake Bay watershed. The Chesapeake Bay watershed covers parts or all of 7 states on the East Coast, and they subsequently have more than 11,000 members in the Chesapeake Stormwater Network. Tom Schueler has more than 30 years experience in stormwater practices designed to protect and restore urban watersheds. He currently directs the Chesapeake Bay Stormwater Training Partnership, which provides webcasts, workshops, and online training modules to train engineers on new practices. Tom also serves as a Stormwater Technical Coordinator for the EPA Chesapeake Bay program. Prior to founding the Chesapeake Stormwater Network, Tom also founded the Center for Watershed Protection in 1992, from which he retired sometime about 2000. I'm not sure when. I first became aware of Tom Schueler shortly after entering the stormwater field in 2003. We were doing some work to develop cost and effectiveness relationships for stormwater best management practices. And Tom's name kept coming up in the literature with Clayton and Schueler, Brown and Schueler, a few Schueler et al.'s, dating back to 1987. Tom is an advocate of the KISS rule, having developed the simple method for stormwater runoff that we have used often. David Wood manages the Chesapeake Stormwater Network's annual webcast series and training workshops and helps develop stormwater resources to support their member network. Prior to joining the Chesapeake Stormwater Network, David worked at EPA's Chesapeake Bay Program Office, where he supported programs to help track, report, inspect, and verify best management practices to meet the Chesapeake Bay TMDL. In 2014, the Chesapeake Stormwater Network initiated the BUBBAs, or Best Urban BMP in the Bay Award. If you work hard at it, you can see how the acronym works out. This award is a glib, self-depreciating reference that has become a big deal in the Chesapeake Bay watershed, given to 7 stormwater BMP categories every year. Today, they will be talking about the next generation of urban stormwater practices. So it is my pleasure to welcome Tom Schueler and David Wood.
Thank you very much, John. It's a real pleasure to be with you all today. All my good colleagues in Minnesota and elsewhere. David and I just would like to give you a sense of where we're at in the Mid-Atlantic and what is portable to Minnesota and what should not be checked. So before we get started, let's see, how do I advance the slides there? Yeah, we'd like to dedicate this webcast to someone in the upper Midwest who is a wonderful colleague, Roger Bannerman. He passed away in October, a stormwater pioneer, a good friend to us all, a warm and gentle man, and a fine canoeist. Roger had outstanding contributions to stormwater and water quality in the upper Midwest and across the nation, and was a great friend of mine. So I just want to dedicate this webcast to him and his memory. And also, just on a lighter side, we had an ongoing competition about who could have more rain gardens on their own property, and Roger, of course, won. He was a great man who could practice what he preached, and he was just a stormwater geek like me. As far as what we'd like to go over today is briefly an evolution of stormwater BMP design, some thoughts on the next generation of design criteria, that make our practices more sustainable. And then I'll turn it over to David, and he'll talk about some of the research being done in our neck of the woods on the impact of climate change, and particularly extreme rainfall on our stormwater profession 30 and 50 years hence. And David is also responsible for our efforts on nutrient crediting and stream restoration practices. So I've asked him to briefly comment on where those things stand. You know, one of the things about having 40 years in the profession is that we can see an evolution and improvement as we go by. These slides were all taken in the mid to late 1980s, and it kind of shows how far we've come. In the upper left, we have a mick pond, those little wet ponds serving small fast food restaurants. On the upper right-hand side, you see the shallow marsh trying to mimic a chia pet. In the lower left, you can see a juvenile detention facility. And then my personal favorite is on the lower right, some kind of temple for aliens to come in with the most beautiful riser I've seen in a long time, but providing no water quality. So we really improved our game, and we've done that successively by improving our stormwater design specifications and sizing through stormwater manuals. This is a slide when we measured our progress in terms of manual stackage before things went to Wiki and on the web, where everyone had these big clunky binders. The one on the left is the New York Stormwater Manual. The one in the middle is the Minnesota Manual, and the one on the far right is the Maryland Stormwater Manual. And through all those changes, we've begun to adapt our field over time. My creds, when it comes to stormwater, I was involved with many other colleagues in putting together the Minnesota Stormwater Manual back in the day. We've also worked on the Maryland Manual, Delaware, West Virginia, Seattle, all sorts of places around the country, even in New Zealand. And this is one of my favorite graphics. It kind of the unified stormwater sizing approach that we advocated for Minnesota, with different volumes for water quality, channel protection, and overbank and extreme flood protection. If you look at it really closely for too long, it goes back and forth. It's like an optical illusion. So anyway, what prompts us to revisit our design standards every decade or so? It's kind of interesting. We generally change our landscapes or even refurbish our living rooms at the same basic pace, about once every 8 to 10 years. There's a lot of reasons for it. Often we need to update our sizing criteria, that we get new design storms to reflect a better rainfall record or better forecasts, and a shift to more precise engineering models. It's also the opportunity to incorporate new stormwater practices and fix problems with old ones, and renew the arguments about how much quality versus how much quantity, whether we want to promote infiltration everywhere or deal with the failures of some infiltration, whether we want to increase the size of the contributing drainage area or reduce it. And generally, a lot of the decisions that are made in the manual writing process reflect our dissatisfaction with our stormwater product that we see out there. Facilities that are hard to maintain, facilities that don't seem to be performing their water quality function, and facilities that just don't look aesthetically appealing. So that generally has kind of triggered the process for all of us in the Bay. Almost all of our stormwater manuals are about 10 years old, so we're beginning a phase now of how to update them and what to update. It's been a more contentious process every time we do it, but I just wanted to make a few points today about some of the things that I've been looking at in terms of how we might improve our design specifications to make our practices more sustainable. And I'd like to use bioretention as a case study rather than talk about every BMP under the sun, but also because we've shifted in the Bay region to about 75% bioretention. It's just a very adaptable practice. We've shifted completely away from ponds for reasons I don't fully understand, some environmental reasons, but also just a trend against ponds. So bioretention is our number 1, number 2, and number 3 BMP. And we've also had opportunity to do a good amount of research on it. Our research in the last few years, we understand a lot more about bioretention. It was really just a black box when it was first introduced in the 90s and even through about 2010. But now we have much better information on how much runoff reduction it produces on an annual basis in terms of the volume reduced. We have much better data on pollutant removal, and in particular, the components of bioretention that increase or decrease performance for different kinds of pollutants. For those of you who know us in the Chesapeake Bay, we are incredibly nutricentric. We worry a lot about nitrogen and a lot about phosphorus, and that's our primary goal. But we've also learned about how they're good at removing trace metals, toxics, sediments, and others. On the other side of the ledger, we have our operational experience, which is the experience that we've seen of the product out on the ground. And we find which design elements are problematic. We do more inspections now and find consistent problems that turn up in application after application. When we look at the entire cycle from concept to construction, we find there's certain steps in that cycle which are more critical or at least more prone to failures. And so we try to tighten those up. And in the case of bioretention, we're still arguing about what's the sustainable plant community, not only from a habitat perspective, but from a maintenance cost perspective. And I'll have a few thoughts about that toward the end. Just to amplify some of the points, I think the big shift in the last round of stormwater manuals was the adoption of runoff reduction targets and that the notion of our ability to infiltrate, evapotranspire, or filter over a long time can really reduce annual runoff volumes by 40 to 70%, depending on the underlying soils. And that is really driving the pollutant removal performance and the operational performance of bioretention and all of the similar practices. There's also been quite a bit of work with upturned elbows and internal water storage zones that can further boost how much runoff reduction occurs at the bottom of bioretention areas. And that was a little bit of a wild area, 7 or 8 years ago. It's now pretty well accepted, and it's been implemented in a majority of new projects, but has yet to go into the specification where it's required. So that is probably something that will be a major focus of our next round of improvements. The other thing that we've learned, and this is a slide I borrowed from my colleague Alan Davis at the University of Maryland, who will not be playing Michigan State this weekend, which is breaking news for us because of COVID. But the issue with bioretention, and for that matter, almost all of our traditional gravity-driven BMPs, is there not a lot of mechanisms outside of denitrification to get a lot of nitrogen removal in our standard design. What we end up doing, the research shows, is we shift or repackage the forms of nitrogen back and forth. But until we get it into nitrate and then have denitrification occur, we don't get the reliable nitrogen removal. So a lot of our, apologize for the truck, a lot of our design efforts are trying to figure out how can we provide a more reliable environment for the denitrification to occur. And realizing that in the upper Midwest, nitrogen control is not probably as important as phosphorus control, it may not be as big an issue as it is for you. But all of our urban BMPs in our bay restoration effort, it's really tough to get the nitrogen out. And there's been a lot of work on alternative media recipes for bioretention and other practices, including the sand filters. The current media recipe for us, which is about 85 to 88% sand, meets our performance objectives, but there's been a great deal of work of adding, and much of it inspired by the work of from Minnesota, adding things like biochar or wastewater treatment residuals to see if we can boost the performance. We call them performance enhancing devices. And there's the removal is usually, or the boost in removal rates is usually greater for phosphorus than for nitrogen. And so this is probably an area where our next generation of specs will have more media complexity in their recipe to add some PEDs. The main limitation to moving forward on this is the reliability of the supply of the PEDs to the contractor community. Until they show up as hard and fast requirements and specs, there's not enough to really have a market to produce them in the quantities needed to be cost effective and applied across. And then I think the other thing that we learned early, and other parts of the country have only started realizing in the last year or two, is that, you know, those kind of homegrown, high compost, organic matter recipes are really groovy and they're really nice, but they create low or even negative nutrient removal rates, which is what, you know, is the primary driver for us in the Chesapeake, and I'm sure for phosphorus is the primary driver in the upper Midwest. So the positive factors, you know, we've already talked a little bit about media, the importance of the internal water storage zone to manipulate more denitrification, having good plant cover and root depth to get to, if you will, the prairie root analog is important, not only for evapotranspiration, but to create the macropores to keep the facility biologically active and more porous. The neutral or negative factors, mulch is the thing that we're trying to get away from. It's an expensive element of bioretention construction, and particularly maintenance, because it decomposes every couple of years. So we're trying to get away to from the mulch model. Plant uptake has not been as big a factor as a lot of us thought. And lastly, there were quite a few arguments about how deep the ponding volume should be. Should it be 6 inches, 9 inches, 12 inches, 15, what have you. But it turns out with our current high sand recipe that it's very rare to see a bioretention area that fills to its entire ponding volume because of the very, very high transmission rates. So there's an argument, and I think it's still to play out in the design community, of can we perhaps dial back how transmissive our bioretention facilities are? Maybe drop the sand down a bit to get more retention in the bioretention. And then, of course, we all have our collection of knucklehead designs. Mine are drawn from around the country, but we're still trying to figure out how we squeeze in stormwater and get the performance. And so those kind of design specs and limitations and setbacks and so forth need to be re-examined and in some cases be made more mandatory. The big choice whenever you write a stormwater manual is whether you use the word should or use the word shall. If you use the word shall, it's interpreted that you've got to do it. If you use the word should, yeah, I'll do it if I want to, but in most cases, I'll go for a lower cost alternative. So making those choices, I think, is something that will go. But the one thing that we're promoting is a kind of a full cycle approach where we look at our monitoring data and try to assess how they're functioning, set forth performance standards for what we want our facilities to achieve, then outline the more specific design criteria that lead to meeting those standards, to have more specific construction techniques as we shift over to, particularly with bioretention, more of it is being constructed by landscape contractors and not our traditional big civil firms. We're looking at more numeric inspection criteria to basically trigger whether a facility passes or fails, and if it fails, what specific maintenance tasks need to be done to restore its performance, and when it totally fails, the makeover stage to recover its performance, in many cases just redoing the practice. And the whole concept of a sustainable stormwater practice is that we can say, like a sewer line or a drinking water treatment system, how long will this last? Will it last 50 years and still perform? And I think the big question for many of us, and it's not a big secret, is our practices may physically last for 20 or 30 or 40 years, but their performance may disappear after 10. So we need to look at the duration of performance of a key metric of sustainability. So anyway, yes, just writing what I was just talking about, establishing minimum performance objectives that control design, have specific metrics for practice feasibility, have design criteria that are more weighted to maintain that performance over the entire cycle, using landscape contractors to maintain function over time, and then what do you have to do when the functions diminish to do a makeover to bring the facility back into compliance. So some of the targets, and I think this is where the arguments about the next generation of design come into play, is we want to consistently achieve a numeric performance standard. For example, with runoff reduction, that we would like at least half of the stormwater volume going into the bioretention area on an annual basis to disappear, either into the ground, into the sky, or well after the storm event is over. In terms of pollutant load removal, we feel we can get the following removal rates, which really hasn't changed that much in the last 10 years, but I think the one thing we have discovered is we were concerned that some of the possibility for release of nutrients and even trace metals, but it does seem that the material is being locked up, and so hopefully over 20 or 30 years, the pollutants are accumulating but not leaving the facility. Some of the more prosaic performance targets, we want plumbing that can last a decade or two without failing. It's things like under drains. We find consistently the inflow to bioretention areas, whether they're curb cuts or something else, are a critical point of failure in many, many, many facilities. We want a sustainable plant community that can withstand Minnesota winters, improve practice function, and create some legitimate habitat, even if it's just for pollinators. We've come to realize that there's not a maintenance fairy out there, that we have to figure out as a society how we maintain LID practices. And what we've come to in the Mid-Atlantic is a reasonable maintenance burden that can be handled by trained landscape contractors and not necessarily hardcore engineers. And as I've mentioned before, numeric triggers to define failure and require makeovers. I think we've been doing this for long enough where it's time to insist and impose those the same way you would have in a drinking water or a wastewater system. And I think David will talk more about it, but we want designs that are resilient to increases in extreme rainfall in the future due to climate change, as well as further hardening of the contributing drainage area. Over time, generally more impervious area is added to sites than was originally done during construction. So we need to have that little factor of safety as the facilities are receiving more runoff than they may originally have been designed for. So the visual indicator approach is a rapid way. We've been putting a lot of numerics on it. Our website, www.chesapeakestormwater.net, has a lot of resources for it. I won't belabor them this morning. The one spec, though, I think that comes out is coming up with a bioretention inflow method that works and can be easily cleaned. Perhaps some kind of pre-cast concrete curb inlet that prevents erosion at the entry side slope and reduces flow velocities to non-erosive levels in the bioretention bed. I think that is a piece of standardization of the plumbing that would be very welcomed by the design community and the construction community, and would eliminate about 30 or 40% of the observed maintenance problems out there. So that's, for some graduate student, get a Nobel Prize in bioretention inflow would be a great way to go. Better specs for landscaping. We're sort of torn on the mulch tree model, as I mentioned before, and the landscaping objectives and invasive plant species and how quickly can we, and how do we maintain them. And I think we never really invited landscape architects to the table on this, which was something we should do in the next round. But we want to have sustainable landscaping templates that are easier to maintain and require less mulch. I've been shifting to what we call a mowable meadow landscape that is seeded with perennial seed mixes formulated for the rather dry conditions in the upper levels of bioretention areas, and that grows up and is mowed roughly twice a year, making the maintenance a little bit easier than having to weed, replace mulch, and so on. And this is just some pictures of how it works. Mowing it twice a year, pollinators and birds are attracted to it. You get pretty rapid coverage, although when you have to have a mix of annual and perennials. It takes a couple years to completely fill in, but lower construction costs, no need to get a lot of container stock, conceals trash and debris. And again, the biggest post-construction maintenance cost traditionally has been mulch, and this is a way to do it. And we have to understand that our landscaping crews know how to maintain, they know how to mow. And so that's something that just to throw out there. The last issue that we're kind of confronting is this question about future climate change and fixing the plumbing in our urban watersheds as the 10, 50, and 100-year storms increase in size. The photo on the left-hand side is actually just outside of my office that I'm sitting in right now in Ellicott City. We've had 2 500-year floods in the space of 18 months. And so we have been really impacted by these changes. Urban flooding has really increased in the public's eye in the Chesapeake Bay and elsewhere. How do we manage that? And so we've always tried to manage a lot of different kinds of storms, but I throw this slide up on the right-hand side. You can see in the Bay watershed, there's a very large increase in very heavy precipitation. It's sort of similar to what you have. I think you're at 37%, we're at 71%. But that's probably the big climate change thing that we're focusing on the most. And I think David, I'll turn it over to him to bring this home. But just kind of in closing, I think we have a lot of great opportunities to clean up our profession, to produce better product, and we just need to get back and do it the old-fashioned way, which is to work together to improve our design criteria to make those sustainable stormwater practices. So with that, I'll stop and turn it over to David.
Thanks, Tom. So I'm going to kind of pick up where Tom was leaving it. I'm going to talk a little bit about what we're looking at in terms of climate change conditions and how that might impact our stormwater design moving into the future, the way that we're approaching it in the Chesapeake region, and then talk a little bit about some of the other practices that we're using outside of sort of the traditional stormwater BMPs in order to meet some of our pollutant reduction goals in the region. So, as Tom mentioned, we are tackling how these changing climate projections are going to influence the way we design our BMPs to make them more resilient. In our region, we have done a number of analyses. The Chesapeake Bay program did a pretty extensive climate assessment last year, and we've been working to compare that with the findings from the International Panel on Climate Change, the National Climate Assessment, and some other local university studies. And there's pretty good consensus that we're looking at, 2 to 3 degrees of warming in our region by sort of the middle of the century. Similarly, we're looking at about between 1.5 and 2 feet of sea level rise by that time, including influences from sort of blue sky or sunny day flooding, tidal flooding, which has increased by a factor of 10 over the last 50 years or so. On the precipitation side, we're looking at, in terms of overall increase in volume, we've got a projected 6.5% increase in precipitation volume by middle of the century, sort of as a Bay watershed-wide average in the Chesapeake. But the intensity of those storms are also increasing. And there's been a lot of work done to take a look at downscaling those larger global and regional models to localities, cities, municipalities across the watershed, and we're finding that the 5 to 35% increase in precipitation intensity, where a lot of that additional volume is being concentrated in the 10% or so of our most intense storm events already. So in terms of what that means for our designs, we're looking at in the next 30 years or so, we're going to have our practices subjected to things like shifting vegetation palettes as the storm events, create changing temperature regimes. For some designs that may have trees involved in them, we're already seeing shifts, northward and westward from some of our tree ranges. Also, just more extreme conditions in our bioretentions, as well as they are subjected to more extreme flow events, as well as potentially longer periods of dry or drought in the summertime. We're expecting with more intensity, more sediment mobilization in the drainage area, causing issues for erosion and clogging of some of our practices. And in our coastal or low-lying areas, while maybe less of a concern, or certainly less of a concern in the upper Midwest, it is impacting the effectiveness of our infiltration BMPs in our lower-lying areas as those water tables rise, filling the pore spaces. The water doesn't have anywhere to go. Some of our outfalls are being submerged and whatnot. So other considerations that we're looking at as well. And there's been some work done to see how the pollutant removal efficiencies are being impacted. And, we're seeing anything from sort of no effect at all, because the loading, the actual loads themselves aren't particularly changing. But, are those intensities mobilizing more of those pollutants or whatnot? So we're still trying to figure out sort of how those practices are being affected. So what we're doing right now, Tom, if you can go to the next slide, is looking at vulnerability of our practices in particular as a way of trying to understand how we can improve design into the future. If we can, I don't know if it's a lag on my end or. Okay, thanks, Tom. So, we're looking at our practices again using sort of our upland LID or bioretention practices as a case study here. Where are the practices vulnerable as we move into the future to climate change? Because a lot of these practices are already being subjected to, conditions that are making them fail even under current climate conditions. So, in that sense, their risk is relatively high. Bioretentions are a relatively needy practice when it comes to maintenance, whether it is, existing design flaws related to, an undersized practice or short circuiting of the flow through the system. Maybe it's a curb cut that was undersized, so you get kind of a fire hose effect coming into the practice already. They are already facing challenges that are most likely to be exacerbated going forward. And our online practices that are sort of within that natural flow path, they're going to be the most susceptible as they kind of face the brunt of those additional flows. We're looking at, in particular, erosion, both at the inlet and the outlet of these practices as being particularly vulnerable, of course, to these increased intensity events. Or perhaps, depending on the design, bypass or overflow becomes a concern when we're looking at what their performance is able to achieve. If we have more rainfall, but it's being concentrated into the same number of events, it increases the likelihood that a significant portion of that additional runoff is going to miss our practices altogether. It might protect them from some of those maintenance needs, but it might mean that we are now having more untreated flow entering our conveyance systems and networks. We also expect with that additional sediment mobilization in the drainage areas to get more clogged filter media, depending on what the pretreatment conditions are. And again, some of these might just be, loss of performance types of metrics in terms of what we're looking at rather than absolute failure, but it also is likely to increase kind of just those routine maintenance needs for these practices, which has already been a significant burden for a lot of our localities around the Chesapeake Bay watershed. So we have a lot more work on this front that we've been doing at the Chesapeake Stormwater Network and through the Chesapeake Bay Program Partnership. We have a series of 4 memos that we've been working on. If you're interested in more details on this, 3 of them are out already. The 4th one will be coming hopefully in the next month. The first one is really, we went around and surveyed about 200 stormwater stakeholders across the watershed to look at what their real concerns and current management actions have been to address the resiliency of their stormwater practices. and condensed those findings into a memo to kind of lay out the needs for the program. The second one really lays out for a lot of the kind of modelers and scientist folks in the Bay program structure, what is the current stormwater engineering standards and criteria that are being used across the watershed. It's a very state specific and in some cases locality specific or department specific type of criteria. So understanding, you know, how those are set up and designed, what are the precipitation data that are being used to inform those designs, so we know what we're working with sort of from a regulatory standpoint. The third memo pulls together all of the recent climate projections and research for the Bay watershed. It summarizes those temperature, sea level rise, stream flow data, as well as a series of 5 different downscaling studies that have been done for precipitation to try to lay out sort of the range of expectations and some of the methods. And then the fourth memo, which is coming soon, talks more specifically about those vulnerabilities for our BMPs. Sort of what are the elements that make them most vulnerable? What are the design components that we need to be looking at in that next generation design? And then hopefully that'll inform future efforts to kind of move towards you know, better design criteria for the states, or at least a commitment or agreement to kind of look at ways to improve our practices in the watershed. So, you know, one of the pieces of that last report, you know, Tom kind of alluded to a couple of ways of doing that, but it's really with the goal of sort of replumbing our urban landscape. You know, we traditionally have our practices that are designed to kind of meet multiple objectives, you know, from quantity and quality, and they've done a pretty admirable job. But as we look at, you know, our vulnerabilities, there are ways that we can improve, you know, throughout the design. Sizing is one of those. We've been doing a lot of work to get localized or regional intensity, duration, frequency curves that are projected into the future in case localities want to look at increasing the sizing of their conveyance networks or their stormwater practices to account for future precipitation. But there are also ways that we can look at, you know, media, those performance enhancing devices that Tom mentioned, to try to improve performance, to kind of make up a little bit of ground that maybe we're losing from some of our bypass or untreated runoff, as well as some of those inlet and outlet protection systems that we might be looking at, whether it's the precast, you know, inlet for improving maintenance or creating a little more standardization, or what we need to be kind of looking at some of these methods so that we can figure out a watershed-based approach to improve our resiliency. Shifting gears just a little bit, I also wanted to cover what we're doing in the Chesapeake Bay watershed on other BMP fronts beyond just sort of our traditional stormwater practices. As many of you know, and Tom alluded to, we're very nutrient-centric in the Chesapeake Bay, as a lot of our implementation is heavily driven by the Chesapeake Bay TMDL goals of reducing nitrogen, phosphorus, and sediment. And so there is a lot of, you know, bean counting that goes on, and a lot of different tools that are now in the toolbox for folks that we have to revisit regularly to make sure that they're keeping up with the latest science on those removal efficiencies that we can achieve with these different practices. Next slide. So if you want a full recap, I'll sort of hit on the highlights, but the process that we go through for these is, you know, we go through what we call the expert panel process. We've been doing this since about 2013, and since then we've covered over a dozen different practices. It's a really complex and consensus-based process, which can drive us crazy at times, but I think in the end typically results in practices that are, you know, well vetted and have buy-in from all of our different partners, so that they can actually lead to changes in design manuals and guidance from the state level that can drive a lot of the guidance for MS4 permittees and whatnot. And so more of those resources, if you're interested in digging into any of those in detail, are on our website, which is linked to the page. This is a list of those practices. On the left are sort of what I would call our major BMPs. These are the ones that are far and away most often implemented by the states across the Chesapeake. You know, our new and redevelopment project BMPs, sort of our traditional stormwater practices, you know, are sort of the the foundation for a lot of these programs, but in recent years, urban stream restoration has really taken off in our region. It has become possibly the most popular new BMP, if not overtaking some of our traditional stormwater practices. At least it does in terms of the amount of air it takes up in meetings and whatnot. But we also have, our stormwater retrofits for our older practices, urban nutrient management. What are we doing in terms of fertilizer application, both sort of from a legislation standpoint as well as sort of localized implementation of urban nutrient management plans on municipal lands or parcels. Street cleaning is one of those programs as well. We have nutrient discharges from gray infrastructure, which is, like an IDDE plus type of program. And then we have a bunch of we tend to call them like boutique BMPs, our contributors that might be good for a few pounds here and there, but generally aren't the basis of the program. And that's our tree planting BMPs, septic system upgrades, shoreline management, and things like that. The ones that are highlighted in red, we just kind of wanted to point out because based on our experience and the reductions that we have set up here in the Bay, they're pretty effective phosphorus removers, which I know is an important driver for programs in Minnesota. So they're things that might be transferable to the upper Midwest. Stream restoration is what I want to talk about a little bit more just to wrap things up. This is kind of what I'll talk about to close out. In addition to the work that we've been doing on climate resilience, stream restoration has sort of been our other big project over the last, I guess it's almost been 2.5 years now. Something that we thought might be, a 6 or 8 month endeavor kind of turned into 2.5 years. But I think it just speaks to the demand that there is for improving practice that is really taking off. It's become, as I mentioned, it's like $1 billion market now across the public and private sector in the Chesapeake Bay watershed. It's highly used with hundreds of miles already built, hundreds and hundreds of more miles in the pipeline that are projected to be implemented by 2025. And so we needed some better standards for both understanding the reductions that are coming from these practices, but also, what are they doing kind of after construction? What is our verification procedures for stream restoration? What are some considerations for other environmental impacts aside from the pollutant removal performance that we're looking at? So if you go to the next slide, we basically formed a series of 5 new stream restoration kind of mini panels, expert panels to look at this. And, one for verification protocols for stream restoration. We created a new protocol that was specific for crediting nutrient and sediment removal from outfall stabilization projects. The dynamics of those where they're very vertically driven in terms of their erosional processes kind of necessitated another method for calculating the prevented sediment erosion. We also revisited the existing ways that we're calculating pollutant removal, which is, we call it Protocol 1 for prevented sediment. And then we had Protocols 2 and 3 that included practices that are designed to, reconnect this channel with the floodplain. So the result was these series of practices, these series of reports. Again, we kind of seemed to like that nice round number 4. We ended up with 4 reports to kind of cover those. Again, the link is on the page here. If you wanted to dig into those in detail, I'll just quickly kind of go over the highlights. If you want to go to the next slide, Tom. But before I kind of get into that, I just want to talk a little bit about what would be, at least in our opinion, kind of most exportable to Minnesota. I think that there are a lot of nuggets that can be really useful throughout these reports. In particular, in the prevented sediment memo, there is a framework for avoiding channel armoring. It had been something that we had learned over the first couple of years of implementation after the original expert panel had come out. There had been a shift for getting prevented sediment credit by sort of hardening or armoring the stream banks. And so, setting up a tiered system where, credit is reduced or in some cases not available, depending on the techniques that are used for channel armoring. There's also a lot of guidance on site level monitoring, the importance of not using sort of default rates, but going out, taking pre and post restoration data on, erosion rates or bulk density, soil nutrient concentrations to better tailor results for local conditions. I already talked about outfall projects. In the floodplain reconnection category, we have a lot of mill dams across the mid-Atlantic. So there was a lot of effort directed towards sort of legacy sediment removal to address this accumulation of legacy sediments in the floodplains. Based on the conditions in Minnesota, more glacially carved stream valleys and whatnot, I don't know that that's as exportable to you all. But that being said, there are some interesting information on techniques that are being used in the region, as well as visual indicators, which I'll talk about on the next slide. With the maintenance considerations, we have, to Tom's point about establishing sort of numeric thresholds that trigger maintenance or corrective actions. We wanted to do something similar with stream restoration, while understanding that these are designed to be natural systems that can adjust to some extent on their own after construction. So there's a little bit of wiggle room, but what we wanted to do is a criteria that has a couple of visual indicators that someone that wasn't necessarily an engineer could walk the site, walk the reach, identify those indicators, have that trigger a specific management result. Is there a major compromise, in which case we need to either reduce the credit or take corrective action for that site to try to restore the performance, or is there a level of failure that we need to kind of walk away from it, but to try to trigger those decisions for localities. We also had a lot of updated research on the sediment and nutrient dynamics in the floodplain. There has been a significant shift towards these floodplain reconnection practices in our region. Different methods for getting water out on the floodplain, taking into consideration, based on channel design, how much of the annual flow is actually accessing the floodplain, how do factors like the height of the floodplain surface, the vegetation conditions in the floodplain, as well as soil textures and things like that influencing what we're seeing in terms of denitrification as well. So just to wrap things up, the last kind of point, I mentioned these different approaches that we're seeing to floodplain restoration. The top graphic here sort of shows a traditional legacy sediment removal, where you're basically lowering that floodplain to promote more reconnection, more of that channel flow getting out onto the floodplain for smaller storm events to try to improve trapping and attenuation, as well as some denitrification happening. We also see a good bit of sort of raising that channel bed to try to promote more reconnection and address those really incised stream banks as well. And so, we laid out kind of qualifying criteria and considerations that folks need to address for each of these approaches. So I already kind of mentioned this, so I'll sort of leave it there because I know I see a little 24 number for the questions in the chat box. So I'll sort of wrap up. This was my last slide, just the focus that we've had on each of these other practices in stream restoration in particular as we move into the next generation, because we're seeing more and more of these diverse approaches to addressing watershed pollutant loads in our region. And so thinking beyond just sort of our traditional stormwater practices as well when we're thinking about the next generation of design, I think is something important. So I'll end there.
Thank you, David and Tom. That's applause from one participant, but I'm sure it reflects all the participants, all 145 of us. We only have time for a couple of questions. The first one comes from, I've got to find it, from Mike Trojan. There's a lot of great info on design, O&M plans, et cetera, coming out of research from other sources. How are you getting info out to people? Manuals work to some extent, but they have limitation in terms of research. I'm sorry, limitations in terms of outreach. So how are you getting other techniques besides manuals? How are you getting information out to people?
That's a great question. And we have this 11,000 person network of engineers and stormwater stakeholders. So we provide them webcasts like you all do. They're very important. We do training workshops, or we did before COVID hit. We have our website, and we have every other year a Baywide stormwater retreat to get our folks together. So it's a combination of multiple outreach techniques to showcase the new stuff and the innovations that are driving better stormwater design.
Okay, thank you. The next question is how do you manage stormwater when it comes to chloride pollution? And do you have any suggestions or concepts for the future of chloride pollution of our surface waters and our groundwater?
Chloride is the failure of urban stormwater. We have no evidence that any of our practices are effective at removing chloride because of its solubility. And in fact, Joel Moore, a local researcher, has shown that our practices tend to spread out the high chloride. So it does not just occur during the winter, but it's now coming out through groundwater in the spring, summer, and fall. So we don't have a solution to it yet. There is a TMDL on chloride, but despite the fact we get a lot less snow than you do, we have the highest per capita rate of salt use compared to you all. We don't have a good solution, and it's a failure.
There is a move in Minnesota to move towards street sweeping as it picks up and removes significant amounts of pollutants, phosphorus, sediment for a relatively low cost. Do you have any recent and current thinking about street sweeping?
Yeah, it's the street sweeping expert panel was the most controversial one we ever did. And we did have Bill Selbig was involved in it, and Roger Bannerman and Bob Pitt. My thinking has changed where, heavily influenced by the work that has been done in Minnesota and elsewhere in Madison on leaf pickup in the fall, we think it's a good strategy. We have yet to turn that into an expert panel. So I would discount our street sweeping expert panel. That's why there was a question mark on that graphic that David showed. The rates in that probably are not portable to what you guys are thinking about in Minnesota. So the short answer is I'm a targeted street sweeping program that focuses on leaf fall and spring pollen drop, I think is a very promising strategy. I think we just need to show a little bit more research on how to operationalize it to our public works community. And if we do, I think it'll become a first tier BMP.
Thank you for that. The next question is mine. You mentioned we need more monitoring, but monitoring is expensive. In some cases, in many cases, cost prohibitive. So do you think, is there anything on the horizon to help reduce these costs? Are there ways that we can reduce our monitoring costs and still do effective monitoring?
I can weigh in from just
Go ahead,
one.
Dave.
Yeah, there are ways through, I think partnership efforts that we're seeing a lot in our region. The one direction that a lot of communities have started to go is leaning heavily into the citizen science, route of data collection to sort of supplement their monitoring programs. We have several collaboratives that have been set up in the region to try to create some more standardization of those citizen monitoring efforts, which has been, I think, somewhat helpful for communities. There has also been more interest in partnerships with like USGS, for instance. We actually just had a webcast earlier this week on an urban water monitoring network program that USGS's Water Science Center in Virginia has been doing with a couple communities, and that has been tremendously helpful as those localities partner with USGS, and they're looking to sort of expand that network, at least in the Chesapeake region, and they're kind of looking for partnerships. And so that has been very helpful to the communities who have been able to establish that relationship. So I think it's a lot to do with kind of leveraging those other partnerships.
Let's thank Tom and David for a very nice presentation.
Welcome back. I will now start the panel discussion. I'll begin by introducing each of our panelists. And if I can ask them to turn on their screens as we go through here. It's my honor actually to have our panelists today for this discussion. We've already had a lot of really great questions, and I'm excited for the panel discussion. I'm excited to use the word cloud as a basis for that discussion. To start, I will introduce our first panelist. His name is Jay Riggs, and he is the district manager at the Washington Conservation District. So Jay, from your perspective and experience, how do you relate to this topic today?
Thank you, Eric. I appreciate the opportunity to be here. I just want to first off say nice work to Tom and David. It's always a pleasure to hear their perspective. And just so you know, Tom, I did smile or chuckle at almost all of your jokes. As a virtual presenter, it can be frustrating sometimes not knowing how well your audience is reacting. So I didn't officially guffaw though, so just FYI, you may need to work on your delivery a little bit, Tom. The Washington Conservation District works with federal, state, and local partners to implement our conservation programs. And we work with both urban and rural landowners, are bordered by 2 large river systems, and have a very geologically and ecologically diverse landscape. Accordingly, we are continuously looking for ways to implement the practices and programs that work and adopt new and better approaches to address these challenges. Luckily, I personally have been able to work with a number of very smart and talented professionals to help guide my perspective on this, and many of whom are here today. And I want to thank all of you. You know who you are. And the WCD is also working to improve and implement intensive prioritization efforts, which actually are originally based on protocols developed by the Center for Watershed Protection, and to identify where we should focus our efforts. So we appreciate learning from Tom and others for their pioneering efforts to improve our approaches in Minnesota, and I look forward to the rest of this discussion.
Great. Thank you, Jay.
Thank you.
Our next panelist is Della Schall Young, who is a principal and owner at Young Environmental Consulting Group. Della, from your perspective and experience, how do you relate to this topic?
Thanks, Andy, and thanks, everyone. As an organization that focuses on providing water and natural resources services, we really work with our clients to think about meeting regulatory requirements, but thinking much broader than that. How does it fit into the ecosystem? How is this practice that you're looking to implement, how can it be continually reused, right? I think sometimes we go in and we think about a specific issue and we design to that and not think about the broader landscape. And that's really what our company does, and how we help folks think about stormwater management and just water management as a whole.
That's great, Della. Thank you. Our next panelist is John Loomis, who is the Water Resources Program Manager at the South Washington Watershed District. John, from your perspective and experience, how do you relate to this topic?
Thanks, Andy. Thanks, Tom and David. I guess currently how I relate to this topic at South Washington Watershed District is trying to get these BMPs, especially larger BMPs, installed in appropriate places in the district to meet our flood control goals and our water quality goals. And being a small watershed district with 4 employees, that necessarily means working closely with our various cities in the district, and especially their public works staffs to get BMPs installed and operate and maintain them and make sure they're doing what we all hope they're doing.
That's great. Thanks, John. I will not ask for Tom and David's relation to the topic because we just had a great presentation from them to set the stage for this topic today. So I'm going to jump into questions, and I'm going to start with actually this word cloud. And I want to thank all of you, the participants, for contributing to this. Again, the link is in the chat if you'd like to add more words as we continue this discussion, and we can watch this word cloud evolve over time. But I want to start by getting insights from our panelists. So what do you see? Looking at this word cloud, I noticed some big words: maintenance, climate change, cost, multiple benefits, designing for maintenance, resilient, things like that. I'd like to know from each of you as panelists, what are the insights do you think we need to include in our discussion based on this word cloud that we maybe need to expand on beyond what we saw in Tom and David's presentation?
Well, I can jump in there. I see a lot of resiliency, climate change, forward looking. And to me, that means risk management. So as we design BMPs, it's planning for failure, trying to build resiliency to combat that failure against what we think is coming. To make sure that our communities are at least protected and hopefully also making progress on our goals at the same time.
That's great, John. Anyone else?
Yeah, I can add something. Oh, go ahead, Jay.
No, Della, go ahead.
You know, as I look at this, the one thing that continually sticks out is the interconnectedness of that outreach question that Mike Trojan asked about. As we think about, stormwater management is not, we can't think about it in a one-dimensional space. It's not just this thing that we're doing just to meet this regulatory requirement, right? It affects so much more. It affects groundwater resources. As we're learning, as Tom mentioned, thinking about chloride, it affects our precip. I mean, it affects so much that we have to think about how do we integrate others that may not just be in this stormwater space, but they could add so much to the conversation and add innovation in our ways to approach this. So, in hearing what John had to say, it's really amazing to have to, to look at, if I'm thinking about my client, how do I integrate the watershed professionals? How do I make sure I'm thinking about the universities that we have around here with students thinking about these issues and bringing them to the table? So this is what I think about when I see this word cloud, the need to bring all of us together to think about how do we make this a truly sustainable practice in the future.
That's great, Della. Go ahead, Jay.
Yeah, thank you, Della, for that. This is a great diverse list of topics. I do want to note that Tom and I did have a pool going on which word would be the biggest, and neither of us won, but I do think that I was close to winning, Tom. But I just want to kind of add on what Della was saying and what John was saying also about, this is a diverse and complicated list of topics that we need to address into the future. And as the former co-chair, and I'm gonna drop mids in here, as the former co-chair of the Minimal Impact Design Standards Work Group, I saw how diverse stakeholders can work together to develop consistent standards to address our stormwater issues. And I think, like Della was saying, we need to bring these stakeholders back together to continue that work to review and update our approaches to stormwater management. This stormwater manual is a great tool. We also have the MIDS calculator and the MIDS ordinance package to kind of bring out to landowners. And these are effective tools to have broader adoption of these simple, consistent, and effective standards at a statewide scale. And I I encourage all of us to look at ways that we can both update and promote these great tools, come back together to have these conversations about what we should be doing next as a larger group, and consider incorporating them into things like, oh, I don't know, our large scale planning efforts such as One Watershed, One Plan.
That's great, Jay. Tom or David, do you want to chime in at all on the word cloud and what you see there?
Sure. For me, it just kind of strikes me the way in which the words that are popping up, most often are just so interrelated with each other. The way in which I think when we first started looking at climate change, at least I was thinking of it more in its own kind of silo in terms of, sizing criteria and things like that as we look at precipitation. And, we really, part of it is, as we went through it, realizing how much maintenance is really a driving factor, or a consideration when we think about climate change. It might not always be, the catastrophic failure of a BMP or a practice, but just the steady increase in more and more maintenance. It's already a huge challenge as we've moved to this highly distributed, model that, we have hundreds and hundreds of bioretentions spread out across our, cities and whatnot that each require maybe, one extra visit or something like that, as we look at climate change and resilience. So I think, linking that into how we think about future costs for updating, designing for maintenance and whatnot, I think those things really all play in together.
That's great, David. So I want to jump in a little bit. I want to tag on what Jay said and what Della said, and I don't want to let it slip away. And what I heard was engagement, collaboration, stakeholders, right? And we see that kind of in the word cloud. And given the current climate and the current circumstances where we have to be socially distant and working remotely, I'm very interested to hear if any of you have had really successful ways, alternative ways of getting engagement, collaboration, stakeholder engagement and input and feedback under these current conditions. Has there been anything new and exciting that's really worked well for you that maybe you didn't expect, or maybe you expected it, but it's something you've had to implement because of the current conditions where we can't really meet in person?
I wouldn't call it new and exciting, but we can reach out to more people using a lot of these virtual approaches, and things like word clouds and other input mechanisms that you can use in some of the interfaces. Actually, I think have a good opportunity for people to provide feedback where you can get immediate kind of work on a whiteboard, but something that oftentimes works for the shyer folks in the audience where it's more anonymous, so you can get more feedback sometimes.
Yeah, this is Tom. I would say one thing we can do is go outdoors and take a business hike with your local inspector and basically get that operational wisdom that they see every day. And that feeding that back in the design process is the missing gap that the inspectors go, those morons who write the design manuals, they always forget this stuff. Well, it's a good opportunity to go and be outside. Although I guess for you guys, the ice fishing season is starting pretty soon. But David and I have a business hike every week or so, and it helps get us on the same page because we're on a Zoom recovery program otherwise.
I need to sign up for that.
That's actually great, Tom. I'm gonna adopt that because I think it's easy for us to, sit in the house or wherever we are and think about, as Jay mentioned, this old technology that we're now just integrating more into our normal lives. What I'm finding in terms of the engagement component, I'm actually seeing more people turn up. And that is because they are, interestingly, more available. I mean, when you take away the hustle and bustle of running all over the place, Now you have the audience and the intentionality around the topic. So what I've been finding is more engagement, and we've been doing it a multitude of ways. So we're integrating surveys, we're integrating the chats, we're integrating a bunch of different things. So if you do have shyer people in the audience, they can type their stuff and then they get their questions answered, and then there you go. As well as, you know, if there are people that want to talk, they can go ahead and do that. But I do think, Tom, that hike that you mentioned is a really good idea. You know, it's really important for us to get out and see these if we can socially distance and really work towards, you know, looking at the resource and using the time that we have now to really study it and engage others on potential approaches to enhance it. Because what you mentioned in your talk, I keep coming back to, and it's that makeover. And it's that constant thinking about, what are we doing with these things? So now we built ponds and they're sitting there and they're not performing as they're supposed to. And now we're thinking about new things to integrate into the landscape, right? What about those ponds? How can we go back to those ponds, or why don't we go back to those ponds and reimagine them, right? It may be expensive, but there are a lot of smart people on this call as a part of the attendees that we can reimagine something with the resources and the infrastructure that's already there. But I think that makeover piece, it just keeps coming back to me, Tom.
I like that too. Go ahead, Tom. So I think that's great. Does anybody else want to chime in on the collaboration feedback topic? I'm going to move to a new question.
I would just echo what Della said, kind of anecdotally, you know, as taking this time to build on partnerships, establish new partnerships with your communities. You know, back in normal times, it would take, you know, a month or 2 months of lead time to get a meeting with all the appropriate stakeholders in the room. Now, if I had to schedule something, I could get it done in a week, maybe 2.
I found the same. It seems like you can get connections with people. They are seemingly more available just with the flexibility that we've been able to experience. So I want to slide topics a little bit. I want to go to one of the questions talking about engagement, right? Engaging the audience. I do want to address a couple more of the questions that came up for Tom and David's talk, because I think we can get some good insights from the panel members for local Minnesota as well. So the top rated question actually that's still open is, what are we using as a replacement for mulch in these bioretention practices and other practices? What are people finding works well and is successful in these type of systems?
Well, we're having a lot of trouble with mulch, like I'm sure everyone else is, especially with the past couple of summers with the more intense, more frequent rainfall. It's washing all that mulch down into the outlet structures and clogging the systems. So we're working through this topic right now ourselves, but it seems like the direction we're going is to use that mulch initially to help stabilize the bottom of a new basin, but then over time stop using the mulch and then switch to or switch types of mulch to more of a rock type of mulch where there's erosion, where we need that additional velocity reduction.
Yeah, this is Tom. I forgot to mention that during the presentation, but we use from spec perennial seed mixes, partial sun, and the idea is to get that established pretty much the way you would do at an erosion and sediment control site. It's a mix of annuals and perennials so gradually the grasses fade out after a while and you get the more meadow. And it's the great advantage is the cost is like $45 a pound for the seed and for rain gardens and small bioretention. it gets pretty good cover pretty quick. So in some cases, you might need some geofabric or initial thin mulch layer to prevent the weeds from coming in. But the sooner you get it established, it works pretty well. And, you know, it's not that impressive in the winter, but in the spring, summer, and fall, it's really attractive. And it also, I think, helps with the invasive species problem. That, because we have, in the normal mulch situation, a stressful environment, it's conducive to invasive plants, whereas here all the competitors already got a head start.
I want to add quick too. I think the problems with mulch that people are experiencing is as much a more design issue, that we need to have these bioretention systems offline and have high flow bypasses so the mulch isn't being flushed. That's a major consideration, and that will address a lot of the other issues. I think when we talk about more intense storm events, larger, longer events, et cetera, it reduces the amount of sediment within these systems if it's done properly, along with good pretreatment.
Other comments on that? So that was kind of narrowed in, kind of specific on design. Let's back it up a little bit higher level again and go to the next question. And it's actually a great question for this context when we're thinking about the next generation of urban stormwater practices and if we want to make them sustainable. There's been observations that flood control and low impact development or green infrastructure should be considered separately, that they have different, that they can't solve both problems with a single practice or a single treatment train of practices. So the question is really, could you comment on the role of low impact development and green infrastructure, or lack thereof, on conventional system sizing and flood control design, the way we do things today? Is there anything there that you've seen that maybe is the next generation of practices that checks all the boxes for us?
I totally agree with Brett's question and comment there, or the implication there that, you know, one of the issues is that we may have more innovative site scale BMPs, but we really haven't moved forward in Minnesota on doing true low impact development or green design. So our planning and site design does not address impervious reduction and impervious disconnection and a lot of those opportunities for reducing, very cost effectively reducing runoff volumes and pollutant loading from the beginning, so we have less to actually treat, you know, and with distributed controls or at the end of the pipe. So I think that green infrastructure and site design issue is something we really do need to look closer at in Minnesota. I think one of the reasons we don't do that as much is because we are very single parameter focused, and our cost benefit analyses and our TMDLs are focused mostly on phosphorus and those single parameters. And so we need to look at ways to achieve multiple benefits and ecosystem scale services from our practices and programs. And to do that, we need to credit those multiple benefits better.
Yeah, I think it's tough, and I think it's a matter of scale and certainty. If we're looking at flood control, and when we look at flood control, it's regional flood control. You know, we're talking about a lot of water, and we need a high degree of certainty that what we put in is going to work. More so than we need to put in a filtration basin or a biofiltration basin somewhere. And I think some of the other questions get at, you know, trigger points, and it's, you know, we put in a biofiltration basin or a filtration basin. If it's working at 60% of what we hoped, we're still getting something out of it, and that's good enough in a lot of cases. That's not good enough for flood control. So that's where, you know, for us, for regional systems, they're still pretty separate. You know, hopefully someday we can get to a level of certainty in operations and maintenance for some of those green infrastructure practices, or they become widespread and use enough that we can count on them to provide some of that benefit. I just don't think we're there yet.
Other comments?
Yeah, I think very quickly to get to John's point, we have this disconnect between where in the watershed we're trying to accomplish it. And if we choose with LID to do it in small areas upstream and do flood control downstream, we'll be creating a dual system. And then we get into all the issues of online and offline for our practices. It's very difficult to truly have an offline practice work upstream under extreme conditions. So I think as a profession, we really need to get the, it's been remarkable to me how the flood control people and the water quality people don't occupy the same space. And why that has not happened for the last 30 years, I just assume they were more boring people, but they're not. They're very nice. And figuring that one out is probably more important than getting better intensity, duration, frequency curves that we have, as someone said, multiple benefits at a watershed level. And we've sometimes lost sight of that quality and quantity are both objectives that the public wants us to solve.
And I'll just quickly add one other thing to something that Jay mentioned. There has been some work in our region with some of these more site design types of practices. We recently just kind of went through an effort of reinvigorating an impervious cover removal BMP, and there was an impervious cover disconnection expert panel a few years ago. We've been working a lot in sort of urban forestry spaces and ways to promote tree canopy expansion and urban forestry practices within our areas, but it's still been very heavily water quality focused, in terms of the pollutant removal performance of those. And there hasn't been as much emphasis on what they can provide or what those benefits might be, if any, in terms of a really quantifiable amount, at least for an engineer, for water quantity purposes.
It just sounds to me as if, as Tom mentioned, and just looking at the entire picture and just bringing more people together to talk about the comprehensive landscape. A lot of times when we go in, it's like, I have a water quality issue and I'm going to address that. Or I have a flood control issue and we need to address that. And just looking holistically at the issues and the topics we're looking at, be it water quality, water quantity, whatever the issue is, but looking at the entire landscape and thinking how we can integrate different practices that may minimize or reduce the down channel effect practices that we have to put in. Might you have to put in something smaller to address flood control if you're really, storing water in the landscape? Looking at, somebody mentioned in here, integrating biochar or other methods into really helping the soil retain more water. I don't know the answer to that, but it feels like if we're doing more upstream, the problem downstream isn't so large. But yeah, it just seems like we just need to be doing more in the upstream and together.
So add one other comment to that, Andy, is that, as we build out these downstream flood control BMPs or systems, but continue to work upstream in the watershed on water quality projects that also retain water, that gives us more resiliency for those downstream systems.
Yeah, what I hear from all this is we can't put all of our eggs in one basket, right? We can't rely on one type of practice or one solution or one even location to satisfy even just one of these goals, right? We can't solve all flood control with one pond or a series of ponds. We need to have a diversity of practices throughout the landscape, throughout the watershed, to all play a part in all of it, right? We should be thinking about all the goals and trying to achieve success through a multitude of ways, so that even if and when, not if, but when one or more of these fail, it doesn't ruin the system, right? There's many, many, many working parts. So that's what I hear out of that. So taking that concept, I want to ask a question about sustainable, right? Sustainable is in the title, Sustainable Urban Stormwater Practices. So thinking about the word cloud, thinking about the discussion we've had, what does it mean to be sustainable when we're talking about urban stormwater practices?
I can jump in just with a point from, the Tom's part of the presentation actually. And, I think a lot of it is thinking about it in terms of that full cycle approach that we have focused on, and it's thinking about these practices in terms of their entire lifespan, from sort of initial site selection, what were the data you collected to make the decision about where the project is located and what risks it might be subjected to under future conditions. And then, what are your clear performance targets that you're trying to achieve so that after you get to that stage of, implementation, what your, maintenance benchmarks are and, how that's going to be performed over time. And then what is the level of degradation that you're going to look at, if any, that's going to say, okay, here's where we trigger some sort of an action, whether it's to make a makeover, a full-scale overhaul of the practice, or can we just do, some minor cosmetic fixes and things like that that are to tune it up and keep it performing the way that we want. And I don't think it always has to be, or it certainly doesn't always have to be going out with, inflow, outflow monitors of nutrient concentrations or anything like that. It can be these visual indicators that we've used in the Chesapeake to try to identify problems early on in the process so that hopefully, you can do those inspections a little bit more quickly and keep your practices functioning longer into the future so that you have to do less big makeovers.
Thanks. I think sustainable means a few things, but on one side of the process, we need to focus more on green practices and non-structural approaches to stormwater management where possible. And when we do have to use structural practices, that we integrate the long-term costs and maintenance and makeover into it. That term makeover is something we haven't used in Minnesota, and we're going to definitely incorporate that term here. And I want to give a plug to our maintenance crew that we have here at the Conservation District. Over the last few years, we've been actually working with our cities and watersheds to have crews go out and do maintenance of these public infrastructure systems. And that program is growing because of that that demand and need for doing that work. And it's one of those things that as stormwater, professionals and stormwater entities, that historically has been something that we just presumed the cities would take care of. And I don't think it's fair to just rely on the cities to be responsible for all these practices that we're making them implement or designing for them, that it needs to be more of a team approach to long-term maintenance.
Yeah, thanks for those responses so far. I really appreciate the idea of considering a BMP in the full life cycle and how things change and you react. And Tom, I think you mentioned also the need to find a way to incorporate that full cycle of thinking into public works operations. I was sitting here thinking of if I go into a meeting with some of our community's public works staff and talk about, yeah, at some point down the road, we're going to have a makeover for a BMP, I'm going to lose them, right? So it's finding a way to, take that idea, but translate it to ways that they already operate in, which to me is no different than, doing a roadway rehab or a mill and overlay every so often. It's just trying to define what those ideas mean in ways that public works staff understand, and try to put some kind of time expectation on it as well.
John, I think you just hit it on the head, you know, because as I'm sitting here and thinking about the same thing, it's like, you know, and as Jay mentioned right before this, you know, when you're thinking about urban stormwater practices, it's like money, cost, cost, cost. Everybody's thinking about the cost, right? So how do you translate this into something that is a recognizable feature for folks that are dealing with this on a daily basis? Change it into addressing the costs. What are the return, what is going to be the return on investment if you do a makeover, right? So let's think about the makeover and talk to it in terms of the fact that maybe doing a makeover here now requires you not to do a pond or another BMP in another location, because now you have enhanced this practice and now it's doing more than it ever did in the past, right? But I think that's really going to have to be the way we communicate with folks in order to bring them to the table. Because I mean, a lot of times when we're coming to the table about, you know, stormwater practices, it's like, okay, another regulation, come on. And if we can translate that into something different, I think that's where we're going to grab them, John.
My suggestion, John, is to call it a stormwater day spa, and we can, you know, do a makeover and look real nice.
They'll like that.
Other comments on that? So that actually leads pretty well into the question I wanted to ask next, and that's barriers. You know, what do we see as barriers to implementing some of these ideas and concepts? And sometimes it's the terminology, right? Sometimes it's the methods by which we try to communicate. And sometimes it's something else entirely. So what do you see as some of the barriers right now that's holding us back from ushering in that next generation of urban stormwater practices? And hopefully you might have some ideas for how to overcome it.
Unfortunately, I don't have any good ideas on how to overcome it. I will say we seem to be aging out of some of it, as some of those long time, you know, old school public works engineering folks retire and are replaced with people that are more open to other ideas, because it's not something they've been doing one way for 40 years. That's working for us, I guess, waiting it out. Unfortunately.
Thanks, John, for saying that. I'm glad I didn't. I think that one of the barriers is the lack of credit and incentives for green infrastructure. That we need to have, our system needs to credit that more, and there needs to be a little bit more of a drive for that to come into the design phase of the process and not the SWIP phase of the process. Because that's what's happening now, is that the stormwater BMPs are responding to the design isn't driving the BMPs. We also have a failing urban infrastructure, and that's going to create a lot of barriers to implementation. Retrofitting is extremely challenging because of tight space issues, but also the way that we have developed our communities with utilities. Their utilities are in the way all the time for a lot of the retrofit projects that we're looking at. That single parameter focus, I think, is going to be a problem and a barrier over the long term for us to really truly address stormwater issues. A barrier that has been in place, and I think this is a little bit what John was alluding to, is our contractor skill is actually catching up with design specs, that we're seeing fewer and fewer contractors not know at all what to do. I mean, there's still some issues out there, but that is less and less of a barrier.
This is Tom. I think one thing is to use the regulatory system to set some drivers. And we have our Bay TMDL, and all of the action that we're getting is because those load reductions are enshrined in MS4 permits. And because of that, it puts it on the inbox of the guy in Public Works or the gal in Public Works, that this is something they got to do. And I was being frustrated earlier that we worry so much about nutrient reduction that habitat restoration is not on the same par, but at least it's a driver for implementation to go beyond stormwater for new land development, which is, you know, what our profession started as we were fixing the mistakes of the past, you know, with new design criteria for new development. But the only way we can do makeovers is if we have a little bit more drivers that are environmentally sensible. And you know, maybe phosphorus would be a good one for you all. There was a great question earlier about, you know, whereas stream density watershed, whereas you all have a lot more wetlands and lakes because of your glaciation. I'll stop there.
I guess what I'll add is just incentivize the behavior you're looking for, right? So it seems really simplistic, but that's really what we need to look to, right? So if we want people thinking about integrating these topics, these practices, or just a different way of thinking, we want them to integrate that stuff at the beginning of the life cycle. You know, starting to retrofit and think about that down the road is quite difficult, as Jay mentioned. But if you're thinking about it upstream in the life cycle, maybe you put all those things in there so that you don't have challenges coming up. But I think up and down, you have to incentivize good behavior. So as you think about the folks that are about to retire, you know, nobody wants to, well, maybe I shouldn't say nobody. Nobody wants to leave a legacy of, you know, problems in the ground, right? So once you approach it in a way of, wow, man, let's put some heads together and see how we can make this better or different, or just something that helps them think about it in a new way. And I totally get it, John, because I've worked with so many people that you're like, oh, here's something new. And they're like, yeah, no, that's a headache for me. I don't even want to look at that, because now you're creating a maintenance nightmare. You're creating all this stuff that I don't need to deal with. I know how to do it. I'm going to do it this way. And, you know, sometimes if we look at incentivizing them in a different way, maybe is around getting their bosses interested or somebody they respect interested, it's going to require us to do more work than just that engineering design and put it in the ground and be done with it. We have to deal with the people that are putting all these things in place. And that's going to be where the challenge is and the opportunities are.
So that actually leads also well into my next question, and that's, we talked about, I heard mention of crediting systems, right? Incentivization, regulations even, and policy. So we talked about stormwater practices, right? The next generation. And that's not all structural, right? We talked about that. We also need to think about these non-structural practices that we also need to incentivize. But then what about policy and regulations? What might the next generation of urban stormwater regulations and policies look like? And how does that marry or match well with what we want to do with our structural and non-structural BMPs?
I can jump into that quick. I'm going to answer your two questions at the end that you had, Eric. First of all, I want to point out that in Minnesota, we do have very good stormwater standards. Very consistently implemented, especially in the metropolitan area by the watershed management organizations. We have MIDs. We also have volume control in our state construction permit. So a lot of these issues are being addressed and have been evolving pretty rapidly. And I think are doing very well compared to other parts of the country. Some of the things that we're seeing that are improvements, I see, our soil media refinement and improvements, our iron and other enhancements, and our pre-treatment requirements and technology, I think, is an important one that we really need to look into, is to have more specific requirements for pre-treatment. That's getting into the stormwater manual, but I think we need to be clear about that requirement. I also want to put a big plug in here right now for the one of the best pretreatment BMPs we've been using over recent years is the Anoka Conservation District's Rain Guardian. I also love their naming conventions of the BMPs that they offer of the bunker, turret, and foxhole as a former military brat. We've been using a lot of those with great success. So Rain Guardian. Other things that, having some different controls or having specs or regulations that look at how you can modify the underdrain systems with spigots and other controls. Incorporating flooding and intense storm events into the designs are an important consideration for long term. I think MIDS is a good model for regulations and standards, but we need to update MIDS, I think, and also enhance it to address sensitive resources such as trout streams and flooding where the 1.1 inch volume control standard is not adequate. And then I think it was also alluded to before, and Tom's mentioned it, perhaps we need more of a focus on stormwater credits and have more of a trading program set up in Minnesota.
That's great. Thanks, Jay.
Thank you.
Any other ideas for maybe what the next generation of stormwater regulation or policy or even credit systems might look like, or how we might integrate that better to make holistic decisions?
I'd just like to mention briefly that right now we have a kind of a curve, a bell curve, and we have average projects in the middle. We have rotten projects on one tail, and we have great projects on the other tail. So that was the genesis of trying to promote the one thing that probably motivates people more than anything else, which is recognition, which was why we started the Best Urban BMP and the Bay Award, the Bubbas, and we have design jurors who take it very seriously, and we get 75 submissions, and it's a great example is when David was showing his stream restoration slides. We used to think of stream restoration as just something to the stream channel and getting that ideal Rosgan geometry, and we've shifted wethout a lot of official decisions to this floodplain reconnection model where we're trying to create wetland and beaver meadow habitat and things that to me were unimaginable when I started my career. So I just kind of throw out that celebrate your good tail and recognize it and bring that forward, because that's the motivation for the young guns out there to increase their game and then get rid of us old silverbacks and send us out to the island and whatnot. Yeah, you too, Jay. So.
I think there just have to be continual intentionality around the focus and the look at resources that stormwater discharges into, right? So as we continually look at that, we've been hyper focused on phosphorus, and now we're seeing chlorides, and pretty soon, folks, we're seeing a good number of emerging contaminants, right? We're seeing, pet waste being the vector for a variety of things that I don't even know how we're going to get out of the stormwater system, right? So I think our policies will have to continually be that more holistic and interconnected approach, where you're not just looking at, okay, I've taken the stormwater off the road, I've treated it to this standard, and now I can discharge it because I'm thinking about phosphorus. Now it's really more of, what are all the things that we have in there? How is this now getting to groundwater? How is it getting to the atmosphere? How is it, what are we doing with this thing that now is connected to so much more of the water cycle, something that's so in the ecosystem around it. So I think that feels like where things are going to have to go in order for us to, protect and preserve this water that we are going to have to drink and consume. So
I think that's a great point, and something that, kind of tying it almost to the barriers, discussion that we had earlier, is just the competing priorities, especially at the local municipality level. As we've started to talk about climate change and resiliency, there's, you hear sometimes from a local government or some of our partners like, well, we're not really worrying about the water quality stuff because we're focusing on water quantity right now. We're doing flood control and flood management. And so a big task, I think, ahead of us, and the Bay program, in the Chesapeake area has started to work on it. It's been kind of a drumbeat that they've been sounding for a little while now, but it's just starting to kind of get out there, which is, better outreach and messaging around those co-benefits and talking about these systems as addressing multiple priorities all at once. And part of that is thinking ahead to what these other emerging concerns are and trying to get out in front of them. So it's part of the way of thinking already when we're talking about sustainable stormwater practices, that they are a way to get at, if not perfectly, but at least start a conversation around some of these other issues as they come up. So it's, into that mindset.
And I see, that's one of the big challenges here is priorities. Different organizations, different parts of an organization will have different priorities, and even individuals have different priorities, right, in many cases. But oftentimes events outside our control can all of a sudden shift those priorities unexpectedly and suddenly. And then all of a sudden you're having to deal now with something else as a top priority. So it makes for a moving target, right, that we're trying to hit. We have kind of a vision of the end goal in mind, but the path there is not always straight and it's not always clear. So we're getting close to time. We're about out of time for the panel discussion. So what I want to do at this point is close with this closing question. And I want to get key takeaways from each of our panelists. And the question really is, what can we give our audience today? We've had a big discussion on next generation, sustainable, urban stormwater practices. We've talked about policy. We've talked about barriers. And we have this word cloud that gives a really good representation of the challenge before us. We have to balance a lot of things and overcome a lot of barriers to get to that end goal. So that what I'd like to do is I'd like each of our panelists to kind of give a key takeaway for our audience that they can use from this discussion to try to improve water resources, balance ecosystem health, improve the quality of life for all of us and for future generations. And I'd like to go in the same order that I introduced everyone and give Tom the last word, although perhaps that's a mistake. So I'll start with Jay Riggs. Why don't you go ahead and give us your key takeaways from this discussion today?
Thank you. I think in Minnesota, we're very fortunate to have a very strong stormwater community. We have a lot of technical experts. We have very enhanced planning and prioritization efforts in place. We have good standards. We have good state rules and policies. We have this whole new basin scale planning and implementation effort. We have constitutional amendment to fund a lot of these things. And so we're really in a good position. But I think what we lack right now, and what I would really kind of put back to this larger group, is for us to organize and try to reconvene kind of the stakeholder process to help push forward the state of the art, have the local implementers and the designers work with the state entities to help move the technology forward and help Minnesota move forward to protect our water resources that the residents care so much about.
That's great, Jay. Thank you. Della, why don't you go ahead and give us your key takeaway today?
Wow. I'll say that is a loaded question. Just given all the things we've talked about, hearing from Tom and David, and, looking at some of your research, Andy, and just I think what Jay has said is he's hitting it on the head, is that we live in an amazing state that cares a lot about our water and natural resources. And they're willing to do what it takes to make sure that it's in a good place. Now, what we need to do as we move on is think broader and get out of our box and bring more of these people together and different professionals. I mean, when Tom was talking, he was talking about the landscape folks that we need to bring into the conversation. Maybe we need to bring more of the educators so that our young people understand the importance of this and can, you know, add some innovation, right? Integrate the universities. I will continue to say that because that's usually my place for getting what's new, because when I bring in interns, they bring so much knowledge, right? Integrating some of the other professionals into this because they bring a fresh perspective that we may be so narrow in our view of what the next steps might be. They could ask questions or just bring a thought that actually helps enhance this discussion and take us to the next level. So I think we need to think broader and bring in more partners because we can't do this alone.
That's really great, Della. Thank you. John, what do you have to give us for a key takeaway today?
So I think what I am thinking about right now is, you know, being reminded that stormwater and water quality is, you know, relatively young compared to other public works types of areas. And kind of taking from Della's talking about us being very narrow focused and needing to broaden our community. I'm thinking about how do we take our concerns, our ideas to that broader community, our cities, our public works staff, our counties, those on the ground operation and maintenance folks that install things, maintain things, make sure they keep working. And I think we've already talked about it. I mean, that full life cycle idea, how do we translate that to a, you know, language that other folks understand? How do we make sure we're looking forward by getting input from university folks, city folks, residents, and really be prepared for what's coming next?
That's great, John. David, what do you have to give us for a takeaway from this discussion?
Yeah, I think, you know, for me, it's just the being able to think flexibly about how things change moving forward. As John mentioned, it's a very relatively young field and things are certainly not static, you know, whether it is the way in which we think about, you know, the precipitation that we use to design, you know, thinking about projections versus kind of backwards looking, you know, precipitation values, or whether it's thinking about the way that we just learn from past designs. Even some of our best projects is ones that are all the way at the right tail of the curve that Tom talked about. Our Bubba's winners, you know, from 5 years ago have already done makeovers on their projects. They, you know, learned from those projects despite being some of the best, and they had to go back and make changes and adjustments. And so, you know, it's kind of that iterative process of evaluating where we are with the practice and thinking about how we can improve. And it really is kind of that, you know, that mindset of how can we continue to push ourselves and get the most that we can out of these practices.
That's great, David. All right, Tom, you're up with the last word.
Oh, wow, that's dangerous, I'm sure. But no, I think, first of all, thank you guys for the opportunity and all the great insights by the panel. It's always great to hear. And I would just say you've been making progress. You've got stronger programs in most states. You're on the right track. You have a little bit more to evolve to get to where you want to be. And I think the one piece of advice is you're going to need to create institutions that link everyone together, not just rely on a conference every 2 years or something, but somebody that can handle training and outreach for all the community, and quite honestly, allow the private sector to engage constructively with the public sector to make the changes to the rules and the specs and the criteria that make common sense. And when those institutions get created, you move pretty fast. And that's kind of the lesson of our Chesapeake Stormwater Network. Thank you very much.
That's great, Tom. Thank you so much. So this will conclude the panel discussion and the seminar. I would like to thank our featured speakers, Tom and David. I'd like to thank our panelists, Jay, Della, and John, for participating. And I also want to thank all of our audience. We had a great audience, great turnout. Thanks for participating in the word cloud we generated. Thanks for submitting so many questions today. I'm very, very thankful for all of you to make this seminar series successful. So with that, we will close the seminar. Thank you, and we hope to see you next month and in future months for Stormwater Seminar Series events.